right, so I'll start at 5.1 and then we'll get into 8.5. They're both doing the same thing basically. So 5.1 deals with rational expressions. And all we're really going to do out of this section is looking at the domains. And we've already did domains in here, so the only difference is in this section we use interval notation instead of a set builder notation. All right, so first, they want us to find numbers that make the rational expression undefined. We're going to find all numbers for which the rational expression is not defined. Right, they're giving us 9b squared minus 10 over 14b plus 15. And they're doing this in this section because this is what you would do if you were looking for the domain on them. Now, I don't have to find a domain on this. I just got to find the numbers that make my rational expression undefined. So what I'm going to do is we're only worried about the bottom of this fraction equaling 0. So I'm going to find that by setting the bottom equal to 0. And then solving that for the b. Once I got the b, that'll give me the number that makes this undefined. We want to solve for b, so I'm going to subtract 15 from both sides. So that'll bring down my 14b, 15's cancel, and then that side gives me what, a negative 15. Right, then to finish out, we'll divide both sides by 14. So that cancels and I get b is equal to a negative 15 over 14. Okay? So that means that.
I'm sorry, that's 14b plus 15 at the very top of the.
14b plus 15.
Okay.
Let me pull that set back. Yeah. So all you're going to do on these problems is take the bottom, set it equal to 0, and get me those numbers. So that's number 1, and then I'll do one like number 2.
So you divide by 40 the top 14.
And you don't even worry about the top of this fraction, because the top of this fraction can equal 0, but the bottom of the fractions can't equal 0. That's what makes them undefined when that bottom's 0. And that's why that's all we're worried about is just playing with the bottom of it and seeing what values make it equal 0. Let me unshare and reshare this because I got a funny screen up here. All right, so number 2 is doing the same thing. So I've got y squared minus y minus 4 all over y squared minus 10y plus 24. All right, so on this one, same problem. I'm going to take that bottom, y squared minus 10y plus 24, and set that equal to 0. Now we'll say this, I'm going to actually solve it by factoring, but on this part right here, you can use the quad to get your 2 answers on this, okay? Anytime you got the y squared equations like that, you can use the quad. I'm actually going to factor it. So I got a y and a y. when you're factoring, anytime this last number's positive, both of these factors will have the same sign as the middle number.
Okay.
So this will both be a negative. And y'all need factors of 24, that'll add to get 10. So let's see.
3? No, 6. No.
33 is what, 11? 2 is 12, 14. Oh, what about a 6 and 4?
Okay, yeah.
That's the trickiest part on factoring is it's coming up with numbers that multiply to get that last number, but they add to get the middle. All right, now, set both of them equal to 0, get your answers. So at this point, if you put that in quad, you would have got a positive 6 and a positive 4 out of that. But when you factor in, once you get it factored, you got to go on and set them equal to 0 to get these signs changed. So the first one, I'm going to add 6. And then the second one, I'll add 4. So 6 and 4 are the two numbers that would make this one undefined because it would put a 0 in the bottom of my fraction, okay? So for 1 and 2, you're just looking for numbers that make it undefined.
And you said the 6 and 4 make it undefined.
So if I put a 6 in for that y right here, that would give me a 0 in the bottom. Remember, anything divided by 0 makes it undefined. Okay. And since there's a y squared there, that meant there were two numbers that would give you a 0 on that one, okay? All right, now these ones we're going to find the domain. And I'm going to write in interval notation. All right, so this would be like my number 3 here. So they're giving me f of x equals 3x minus 7 over x plus 7. So now I'm actually going to find the domain, which is all the numbers that will work for this. But in order to find all the numbers that will work for this, I got to find any numbers that don't work. And numbers that won't work are the same thing as we done here, that make them undefined. So what I'm going to do, I'm still going to take that bottom, set it equal to 0. I'm then going to solve that. So x plus 7 equals 0. We're going to subtract 7 from both sides. And we get x is a negative 7. So that means I've got to remove negative 7 from my domain. So here we go. My domain, you're always going to start with negative infinity. Now, since that negative 7 makes my domain undefined, I'm going to kick out that negative 7 from the domain by using a union. So this is a union and it means and. So all numbers from negative infinity to negative 7 work. I'm going to union around that negative 7 because that's how I kick them out.
To positive infinity.
And then I'm going to go towards positive infinity. There you go. And be done. So in this section, you're going to all start at negative infinity, and you're going to have a positive infinity. And in the middle, you're just going to kick out any numbers that don't work. Okay? So if I kick out one number, I got one union. If I got to kick out two numbers, I'm going to have two of them unions in there. Okay?
Is this going to be a problem with two unions? You'll show us how to do it with the two unions.
With what?
The two unions.
Oh, yeah, I got one right here, okay. So the one that would have had two unions is sort of like y'all's number 6, actually. So I got f of x equals x to the third minus x squared plus an x plus a 3 all over x squared plus 11x plus 24. So I will say, since I got a exponent of a 2 in there, I'm looking for two numbers that I'm going to kick out of this one, okay? But y'all going to start the same way. I'm going to set all this equal to 0. At that point, you can hit that with the quad if you want to, but this is not bad, so I'm going to factor this one. So x squared would be an x and an x. Last number is positive, so both of these will be positive like that middle number. So both of these will be positive. So this time I need factors of 24 that add to get 11. Oh, and I think that's the one you were saying won't go.
No, I had said
83.
Oh,
83, because 83 multiplied get 24 and they
I
add
think
to
I would
11.
have said 73, but yeah.
No, not that. All right, then the rest of this is set these equal to 0 to get these numbers changed. So it looks like we're going to get a -8 for the first one. And then my -3. So two numbers I'm going to kick out this time, okay?
Why did you get the 83?
Oh, so when a factor, I always look at factors of that last number. And since that's plus there, I wanted my two numbers to equal 11.
Multiply to get 24.
They got to multiply to get that last number, but then add to get that first one. So 1 and 24 didn't work, because they added to get 25. 2 and 12 didn't work, because they added to get, 14. What was that, 3 and 8? 3 and 8 did work, because they added to get my 11, okay? And the only other choice I would have had was a 6 and 4, which while ago worked on my 10, but they didn't work on my 11 at that time. So really, it's just a matter of finding factors and then putting them in right where you can get them to FOIL out. Now, here's the tricky part on this one. I'm starting at negative infinity. Going left to right, which number am I going to hit first? That -8 or that -3?
Negative 3.
So I'm going to go to -8.
Oh.
Then I'm going to union around that -8. From the -8, it'll go until I hit the -3. So now we got a union around that -3. But then from -3, it goes on towards positive infinity. Oh, let me write that again, y'all. I don't think it showed up on my board there. So negative infinity to -8, -8 to -3, and then -3 to positive infinity. All right, so I think that's all. So that's basically 5-1, just finding the domains of these, okay? So the first two look at finding numbers that make it undefined. And then the last few are just finding the domain and putting them into the interval notation. And it's not bad, just remember, we use that union to keep the numbers out though, okay? Hang on, so 8.5, I'll get started, and it has a few definitions right off the bat. This is rational functions. And I'll tell you, anytime you see that word rational, That means fractional, okay? All right, so let me give you all a few definitions. First definition is a vertical asymptote. So a vertical asymptote is an imaginary vertical line that occurs where a function is undefined so it's going to occur at these numbers over here that we were finding in these domains, okay? So it's going to occur where the function is undefined. The graph cannot cross the imaginary vertical line. Okay, they come in the form of an equation, comes in the form of x equals some number. So if my vertical asymptotes were like this, -8, -3, the equation for the vertical asymptote would be x equals that -8 or x equals that -3. Pretty much the solutions you're getting are going to be the equations for these, okay? So to find a vertical asymptote, we set the denominator equal to 0 and solve for the variable. Okay, so basically what we've been doing today would be the way I find my vertical asymptotes, okay? And I'll show you a graph of them. But usually on a vertical asymptote, you have one side goes up and the other side comes down, but they never cross that line, okay? So how about a horizontal asymptote? So let me show you a horizontal asymptote. So I had a graph, and that graph came down and started to try to get to my x-axis here. That would be the horizontal asymptote, because that graph, as it goes out towards infinity, is going to try to get closer and closer to my x-axis, okay? So horizontal asymptote is an imaginary horizontal line that the graph tries to approach over time. Over time. Okay, so it'll keep trying to get closer to these values, okay? I got 3 cases for a horizontal asymptote. All right, so these will be 3 cases for horizontal asymptotes. First case, the degree of the top is greater than the degree of the bottom. So degree of the top is greater than the degree of the bottom. If the top degree is higher than the degree of the bottom, and I'm looking at the highest exponents, remember the degree is the highest exponent. If the top is higher than the bottom, then there is no horizontal asymptote. What happens is the top's bigger, it's just going to keep heading up towards positive infinity and keeps going up. It don't try to get to no lines, okay? If the degree of the bottom is bigger than the degree of the top, so degree of the bottom greater than the degree of the top, then your horizontal asymptote is going to be y equals, whoops, 0. So if the bottom is getting bigger than the top, eventually it's going to try to approach 0, which is that x-axis on there, okay? So top's higher degree, no asymptote. Bottom's the higher degree, it's going to be y equals 0. So notice the verticals are in the form of x equals, horizontals are in the form of y equals, okay? So what if they're equal? So the degree of the top equals the degree of the bottom. Then your asymptote will be y equals a over b, where a equals the lead coefficient of the top and b would be the lead coefficient of the bottom. So remember, lead coefficients are the numbers in front of the variables that have the highest exponents, okay? Remember, if there's no numbers in front of them variables, you can treat it like A1 sitting in front of them, okay? All right, so we're only worried about horizontal asymptotes and vertical asymptotes. In the homework, if they ask you about a oblique asymptote, put there is no oblique asymptote, okay? So it should have a and B choice, go with B that says there is no obliques. So I'm going to list all the asymptotes. So I'm going to list all asymptotes. And then it says graph. All right, y'all, so they're giving me R of X equals 3 over x squared minus 64. So I'm gonna go through and find my vertical asymptote and my horizontal asymptotes. So let me find my vertical asymptote first. To find the vertical asymptote, I'm gonna take the bottom of this fraction and set it equal to 0. So I'm gonna set x squared minus 64 equal to 0. Now I'm going to solve it by factoring again, but if you use a quad, this will be a 1, 0, negative 64 for quad, okay? All right, so if that's going to factor, it's going to factor into two nice parentheses. I got an x and an x. This last number is negative this time. Anytime the last number is negative, you're going to have one positive and one negative inside them parentheses. And notice, there's not an x in the middle, so that's like 0 x's in the middle. What factors of 64 will subtract to get a 0? You're on the right path, though.
32.
Well,
That's
remember, what multiply to get me to 64. And when you subtract the two numbers, you get a 0.
Oh, 8 times 8.
8 and 8, there you go. I'll tell you a trick on these. Usually when it's an x squared minus a number, take the square root of that number and it'll give you your two numbers. Okay? So now we know all we're going to do is change the signs, make one of these positive, one negative. So the first one I get a negative 8. And then I'm going to get me a positive 8. So I've got two vertical asymptotes. That means these are going to be imaginary dotted lines that my graph cannot cross in a little bit, okay? So a horizontal asymptote which means now I got to look at the degree. The degree on the bottom is a degree 2, right? So degree 2 on the bottom. On the top, you don't have a variable at all, so that's a degree 0. Which means my bottom degree is bigger than my top degree. And anytime the bottom was bigger than the top, we said that the vertical and horizontal asymptote was y equals 0. Which means in the long run, as I head towards infinity and negative infinity, my graph is going to try to get to that 0 on that, okay? So let's see. All right. So I know one thing. I know I got two vertical asymptotes at 8 and negative 8. So I'm going to go over here at negative 8 and draw me an imaginary dotted line. And then over here at positive 8, draw me a dotted line. All right, there's one thing I'm going to need, and that's where I'm crossing that y-axis at. So to find where it's crossing the y-axis at, I'm gonna find the y-intercept. So the y-intercept will be 0 for the x value. So y'all, if I put a 0 in for that x squared right here, so here we go, we're gonna find r of 0. That's gonna equal 3 over 0 squared minus 64, which basically is gonna be a 3 over negative 64. That's a really small number, but I needed to know that because I needed to know if it was going to cross on the negative side or the positive side. So that was a negative value. Now, from this side, you're going to approach this vertical asymptote. This will keep going forever towards negative infinity, but it's never going to cross that dotted line, okay? Now, this side is going to do the same thing. It's going to come down. Now, usually on a vertical asymptote, if one side's coming down, the other side's going to go up. So this side is going to come from down here and go. Now, this is where the horizontal asymptote would take. As this x-axis goes out further, that vertical asymptote is going to try to get down to it, get to that 0, but it never can quite get there. But it keeps trying and trying and trying. And on this side, it's going to do the opposite also and come down and eventually try to get to the x-axis. Okay. Now, if you put this in the calculator to graph this, put the bottom in parentheses. If the top would have had more than one part, I would have put it in parentheses also, okay? So y'all pull it up on my little calculator on here and I'll show you how I would graph that, okay? So I'm gonna quit sharing this and pull up my calculator. They're not bad. It's just putting them into that calculator right, you know, to get them right graphs out of it. All right, so let me go back and share this screen now. All right, so I'm gonna go to y equals and clear this one out. Now, I only had one part on top, which is 3, so I don't need parentheses for it. So I'm gonna put my 3 and then divide. The bottom of this fraction does have more than one part, so I need to put that in parentheses. So put the bottom of your fraction in parentheses, and then that was what, an x squared minus 64. So x squared minus 64, and then close parentheses. So main thing I want to do is look at my graph to see which one of my pictures that would have been. So go to graph. And then pretty dang close, right? Now, you notice the calculator don't put the imaginary dotted lines, but you can tell at that -8 and at that +8, one side's going straight up and the other side of them asymptotes is coming straight down. Now, if you look at the table, second graph, and look at that table, let me go up to where -8 was. So at -8, you get an error message for the y value. That means it was undefined. And then if you go down there to the +8 on the x's, you get the other error message. So you're going to get error messages where those asymptotes occur at because it's undefined there. Okay. Now, let me go back to that table, because remember when I was at 0, there's my negative 0.047, which would have been what that 3 divided by 64 would have equaled, okay? So that's why I love them calculators, boy. They'll grab what you need on them, okay? All right, so then I'm gonna get into problems just wanting to find vertical asymptotes and horizontal asymptotes. So these ones we're gonna find the vertical asymptotes. All right, I got f of x equals 1 over x minus 4 squared. So you're gonna set that bottom equal to 0. We know that x minus 4 squared is just the x minus 4 times the x minus 4. All equal to my 0. Which means I've only got to solve one of those to get my equation. So I'm just going to solve one of the x minus 4s equal to 0. Which means that's going to give me what? A positive 4. So x equals positive 4 will be my vertical asymptote. Now I'll tell you what happens on that. Since this has a 2 for the exponent, it won't go all the way through the graph. It would come down and touches the graph, but it don't pass through it. Okay? So even exponents touch the graph and turn back up to where your odd exponents would pass on through it. But all they want to do was my vertical asymptote to be done, okay? There you go, same thing. F of x equals x minus 6 over x squared plus 5x. So set that bottom equal to 0. Now, if you hit this one with quad, so quad, A, B, and C. If you did quad on this, A is 1, B is 5, C would be 0. Okay. We all want to solve this by factoring. Now, it's not going to factor like the stuff I did a while ago, because this don't have a number at the end. This is just the first 2 terms. So when you look at the first 2 terms, you want to see if they got anything in common. Well, both of these have an x in them, right? So since they both have an x, factor that x out like the greatest common factor. Now, if you factor an x out of both of those, inside the parentheses will be the other x plus 5. So that brings back GCF memories. So the x was my greatest common factor, and I just factored it out. But now I got both my factors, so both of these now get set equal to 0. So x equals 0, I cannot do nothing to that, it's done. The second one, I'm going to subtract 5. and again, x is a -5. So for this one, the answers would be these two right here. All right, find the horizontal asymptote. The horizontal, you got three cases: top's bigger, bottom's bigger, or they're equal. All right, let's see. I got a 2x to the third plus 5 over 3x to the third minus 5. So I'm looking at the degree of the top. The degree of the top is a 3. The degree of the bottom is a 3. So they're equal. So the top equals the bottom degree, which means y equals a over b is going to be my horizontal asymptote. So remember, a is the lead coefficient on the top. Well, the lead coefficient on the top is a 2. B is the lead coefficient on the bottom. Well, the lead coefficient on the bottom is a 3. So I end up with y equals 2 over 3. So when they equal each other, you're basically looking at those fractions in the front. Okay? Which means over time, it's going to try to get to 2/3 on the y-axis versus the 0, okay? All right, how about, let's see, those ones were equal. Let's try this one. F of x equals x squared minus 4 over 7x to the 4th plus 2. All right, degree of the top is a 2. Degree of the bottom is a 4. So the bottom is bigger than the top. Anytime the bottom has a bigger degree than the top, this automatically is a y equals 0 for your asymptote. Okay? So the only time you really got to look at numbers is when they're equal. Then it's the numbers in the front. Bottom's bigger, it's going to be y equals 0. Remember, if the top was bigger, then there would be no horizontal asymptote. Okay? All right, so the third one of these is f of x equals x to the third minus 5x squared plus an x minus 4 all over x squared minus 18. So to this, and that'd be where we stop today, because then I don't have like a couple more problems at the end to do, and then we knock out 8-6. And then that's all the material for test 3, okay? So we'll be finished with test 3 material this week. So let's see on this one, the top degree is a 3, the bottom degree is a 2. So this time the top is bigger than the bottom. And anytime we said the top was bigger than the bottom, there is no horizontal asymptote. They all say this, we're not gonna kill you on these asymptotes. We just wanted y'all to be able to tell the vertical asymptotes and the horizontals, because some of y'all might get into the calculus class or something, and they use that a lot in there, okay? Business calculus maybe, something like that.
Do you teach that? No.
I could if but usually the business calculus, the chair for that, or what do you call lead instructor, she usually gets one of those because that's her subject she's the lead for, but there's only like 2 or 3 that they have. So she'll use it, but Cynthia Fletcher's really good at that. Cynthia Fletcher, if she's on there. They won't be showing up until probably another week or 2 for, because we're not, we haven't picked up for the fall yet. Although y'all can start picking classes tomorrow, I think it was, I think. Tuesday.
Yeah, I think it was the 6th.
The 6th. Is that
That
tomorrow?
is tomorrow.
It is tomorrow. Okay.
Yeah, it is tomorrow.
So,
for fall though.
So y'all go in there and then
The summer classes over.
Yeah.
summer classes, yeah, they're open already. And they should have, I know for the math, we all got our names on them already and stuff. Summer 1's going to be 5 weeks of June. Summer 2 is 5 weeks of July.
Yeah, I'm not taking no math for the summer, but I do have business calculus after.
Yeah, I just did summer 2 this time. Same class, college algebra, you know. Everything should be, from what I'm seeing, we should be more normal come fall. If you're face to face, it'll be all face to face. We won't be picking, hey, I'm gonna come Monday, I'm gonna come Wednesday, doing the Zoom stuff. It's everybody's, if you're face to face, you're coming every day face to face. If you're webinar only, then every day you're doing Zoom every day on your classes. So they will give that option still, because some people like doing the webinar stuff.
How does that work out with mixed schedules, like for attendance wise? And then will there still be online material to access?
So when they're online, the ones that are going to webinar only, they are definitely talking about doing some kind of breakout sessions or some way to keep people attendance on there. A lot of them are talking about like midway through or toward the end, just ask them some little question to answer on the chat or something like that. Then they can verify they was there. Because on online, you got a problem with people clock in, but then they go do whatever they want to do. Because we see their name, but we don't see them no more, you know, because the video capability. So I'm just pretty much doing face to face for mine. I don't mind doing Zoom. It's just a hassle to me, I think.
How does that affect for in-person attendance?
Okay, so either way you go, attendance and participation will be 10% of the grade. So if they're never online, but they're doing their work, they might get the 90% is the highest they can get if they don't get that other 10%, because that automatically takes off that percent from their grades and stuff. In class, we're pretty lenient. It ain't like, oh, if you come every class, you get 100. If you come all classes but once, you get something like that. I look at work and attendance and stuff.
Because I'm doing a lot of in-class next semester, but my work schedule doesn't allow me to.
Yeah, so most of the girls are going to work with you if you're coming and they see you're doing your work. That's going to be the main thing now. If they see you're missing and they start getting online and looking around and like, oh man, Nick, he's 3 sections behind, you know, or something like that. Then they might be like taking points off those participations and stuff, you know. But they're going to be really lenient through this COVID stuff. I mean, once we can get stuff going back to normal. But I do know what you won't have is a Zoom class with a face class at the same time. They said if we wanted to record them still to make videos and stuff, but hell, we got enough videos this year, right? Some of them for more normalcy, you know, and because y'all are missing out on one of the biggest things, and that's interaction with other students.
Mhm.
You can't go to the campus center and it ain't gonna be full of people these days.
No.
Y'all, that campus center at lunchtime especially, there used to be hundreds of students in there all interacting and mingling, and they would do poetry readings every Friday or a chess
Right.
club stuff, or
Mhm.
something was always going on, so we need to get y'all back into
I'm
that.
not looking forward to parking though in the fall.
That's the
I
one
know
thing
that's gonna
now.
be a mess.
But they made that big old parking lot across the street over there, so that should help out a little bit. Before we had that, it was really tight. You'd be running from one side of this campus to the other, so.
Right. Yeah.
So, yeah, we'll wrap up test three material Wednesday, and then, that'll give me about a month to do the last, we only got 4 sections left after this, so like 9, 3, 4, 5, and 6, and it's done.
Yeah.
So the actual test will open up Wednesday?
Oh, I'll probably open it up after Sunday,
Next
test
week.
3.
Okay.
'Cause,
cover it.
I'm gonna send out a study guide and stuff for y'all to look at and stuff for that, and so once I get this material out though, I'll get my study guide out there, and then, we'll start the last set of material next week.
Yeah.
Okay? All right, so most of y'all look good in my class.